Welcome again to another episode of the Smart City podcast. Today I'm very happy to be joined by Vineeth Ram, Chief Revenue Officer of OLI Systems. Welcome, Vineeth.
Thank you.
How are you today?
Doing great, enjoying this wonderful conference, and thank you for the opportunity.
Yes, we're live here at the 27th Annual ARC Forum. Vineeth, you're at OLI Systems. And for our audience that might not be terribly well versed in either the technology you use or your company, can you give us just a broad background of who is OLI? What do they do?
Great. OLI really is a trusted solutions provider for the design and optimization of the most complex and valuable chemical processes that are used in a broad range of industrial process industries. Essentially, what we do is we provide predictive model-based insights that help to improve operational efficiency, mitigate operational risk, as well as enhance sustainability and engineering productivity.
So, just walk us through even a simple, application. You're actually testing the components that are within a system and determining the rate of degradation of a pipe or of a piece of equipment, correct?
Yeah. What we do is we really understand the chemistry of the process. So for these complex chemical processes, we develop a very sound understanding based on the principles of thermodynamics and kinetics. And once we understand them, we're able to model and simulate them very rigorously and very accurately. So once you do that, you can start asking a lot of what-if questions and scenarios and trying to adjust. You can adjust your inputs and understand, what kind of outputs you get. So you can understand sort of how to design these parameters and optimize them. And essentially, this is applicable both if you're designing equipment as well as if you're designing your process. And now we've also taken it to real-time operations where you actually can make sure that you're operating them more optimally as well with real-time monitoring and automation.
I mean, for our audience, a few months ago, we did interview Lisa Williams of OLI Systems, and she gave a great, very granular discussion of the actual processes of how OLI Systems goes about what they do. Vineeth here today is here to talk about something relatively new, I believe, in the world of OLI, and that is some of your efforts in the area of sustainability. I know that there's a variety of applications that you cover under that sustainability umbrella. So I'd ask you to go slow and go in detail across some of those. So
Sure. Actually, this is not very new. We've been doing this for several decades in terms of sustainability. We just didn't necessarily coin it as sustainability and bring it to the forefront. But historically, we've had a lot of applications in the handling of treatment of hazardous nuclear waste materials and how you store them and make sure that they are safe and understand sort of the corrosion mechanisms inside them. So that's been one of our early applications where we've actually looked at making things more sustainable. But simply put, from an OLI perspective, sustainability is about, a number of different things. It's improving air quality, it's water quality, it's just driving more reuse and, sort of better utilization of assets and capabilities. It's also, in a big way, driving that decarbonization and energy transition. Whether it be through just carbon capture processes or through, more importantly, clean energy sources. So really a wide range of areas, and maybe now I can drill into each one of them a little bit to give some details for the audience. So really I'll start with things like, greenhouse gas emissions, right? Certainly CO2 is a big part of it. One of the things we are able to do is accurately model CO2 capture processes because we can actually simulate the underlying absorption and regeneration processes that are chemical processes, understand them. So we can actually understand how to design these capture processes in an optimal way. Next, if you come to, once you capture the CO2, you have to transport the CO2. So when you transport the CO2, one of the things we've found is the corrosion in the pipeline is a major problem. Because when you emit CO2, a number of impurities come along with it, right? Like the nitrous oxides, sulfur dioxides, etc. And these impurities really cause corrosion. And they degrade the pipes, and essentially you have loss of CO2 and things like that. So essentially, we have the ability by understanding and building a corrosion model during CO2 transportation to sort of play with the different parameters. So if you're actually an emitter of CO2, you can understand what are the acceptable levels of impurities you can actually have in your CO2 discharge, which are not going to cause corrosion, right? So you basically get some design parameters to understand them. You can also go and do material selection. Clearly in the case of CO2, we want to use the lowest cost material. But in some other applications for corrosion, we can actually design, go and select the optimal material that we want. So that's then moving along to storage. When you store CO2, the same kinds of things come in. In understanding interactions, if you put them into caves, for example, the chemistry and the behavior is still another factor there. So understanding and optimizing that is still an important factor. So the fundamental understanding of chemistry gives you a strong way to play across the entire CO2 capture, transportation, storage. Now, even with utilization, it becomes important when you're building novel materials with captured CO2, which is a big area right now. We find applicability. So this is a broad range of areas we can help with just the CO2 processes that we talked about here.
That's fascinating because it reminds me of the three pillars of sustainability. Actually are protecting or enhancing the environment, which the CO2 capture and transport takes care of. Yeah. The second pillar is called social. So it's quality of life and safety issues, which arguably CO2 capture is there too. But the third one that's often forgotten is economics. Is that if there isn't a reasonable financial model around this, none of those first two are going to happen. And if your system corrodes and is inoperable or is extremely expensive to operate, you're not going to be in a position to capture your CO2. So it's important to do the right things up front so you have an economical, solid financial business model. And certainly testing for impurities is of great importance.
Yeah, absolutely. That's a very good point. In that the economics plays a role too. And just a similar example here, if we think of clean energy like geothermal energy, for example, even in geothermal energy production, there's a big challenge with asset integrity, and corrosion plays a role because similarly you have impurities coming in when you are extracting geothermal energy, and that again causes challenges inside the operation environment.
Let me interrupt. You mentioned some of the impurities in the CO2 capture system. What are the typical impurities in a geothermal system?
So basically, these are to do with acidic sort of acid forming.
Okay.
So essentially, what happens is these impurities form acids during the actual process, which then corrodes the environment. And in geothermal energy, you actually have the benefit of using materials like titanium in certain areas, and especially in the power generation side.
Right.
So there's a material selection options that you can do to actually, and these are coming in at pretty high temperatures as well. So you have the high temperature effect, you have the sort of the acid formation that's happening because of the impurities that are coming in, and that becomes a phenomena as well. But the net effect of all this is what happens is you're actually increasing the cost, right, of production of geothermal energy. And now the levelized cost, right, of geothermal energy, or the cost of production of geothermal energy has to meet the levelized cost of energy production from other sources. So now you really are content by improving asset integrity, you're really making geothermal energy much more cost competitive. And that's, again, to your point, it's about the economics of what's happening.
And stretching the life cycle of that equipment.
Exactly. And so the understanding of the chemical behavior, predicting of the corrosion, really is an important tool in helping to bring that capability as well and drive the market adoption for geothermal energy.
So we talked about the CO2 capture, transport, and storage process. We talked about geothermal energy. Are there other sustainability areas in which OLI works?
Yeah, absolutely. Just in terms of air quality, think of the flue gases that are emitted from a number of harsh industrial environments. That's another area. So we've been doing flue gas desulfurization in a lot of these power plants and other environments for quite some time, and that's a key application which is governed by the Clean Air Act. in terms of that. So that's one area. So in general, all of these greenhouse gas emissions and flue gases, that's a kind of big area for helping to essentially manage that whole process and mitigate those contaminants in the environment. Which is big. Next, I would go to the water quality side, right? So again, a lot of the water chemistry and electrolyte behavior sort of governs what happens when you do water wastewater treatment. And this can be multiple sources, right? Whether it be an industrial wastewater, whether it be seawater desalination, all these things become extremely important. And through rigorous modeling, we can actually understand what are the toxic contaminants. Typically, you have heavy metals in there, like arsenic and so on, which are have very harmful effects on the environment. Those kinds of heavy metals, you can actually detect them and actually make sure that those are not being released into the environment through your modeling and simulation. In addition to that, another big area in water treatment is just energy consumption, right? Optimizing energy, because a lot of times what you find is just optimizing energy consumption and minimizing the energy use lowers your costs, but it also makes you more sustainable. Because we know that most energy sources really are coming from, most power plants are powered by natural gas even today, right? The renewable sources are very small. So that gives you another added effect. So with the modeling, understanding the steps in the process for water treatment, let's say you're doing filtration through a reverse osmosis or some other process, you can actually understand the dynamics and then optimize your design to minimize energy consumption. Right, which is another area. So this whole area of water, wastewater treatment is another area which pretty much is ubiquitous in many different industrial processes, right? You're either using them in the chemical process or you're discharging them afterward, right? Or you're just extracting them along with your oil or with your metals, right? So that's kind of another big area.
That's fascinating. I know you touched on a few other areas, like electric vehicle batteries.
Yeah. So that's another fascinating area. We're all seeing the huge growth in demand of electric vehicles. One of the key things to note there, as you probably know, is the supply of raw materials, right? The critical materials is heavily constrained. And based on the estimates that you're looking at, in the next 10 years, we won't be able to keep up with enough supply to meet the demand of these critical materials, right? Like lithium and nickel and cobalt and manganese, right? These are critical materials required for electric vehicle batteries, and one of the things that we are doing at OLI is we're working with many of the major operators around the world to essentially do a better job of more effectively extract, purify and refine these critical materials, right? With the effect that you can increase yields and lower cost through various processes, whether it be evaporation or separation. So, for example, for lithium, we can extract it from brines, the salar ponds that you have in South America, or from ores, which is typically predominant deposits in Australia, or we could also extract from geothermal brines, which is a very, very big emerging area where now the EU has declared that 30% of the lithium supply by 2030 should be coming from geothermal brines.
Wow, that's fascinating.
So this is again an area we've had a lot of experience in, and we've worked. In fact, in the largest project in the US, we've actually done significant work on extracting lithium from geothermal brines.
That's a fascinating set of data points and all those different applications. What do you see for the future?
So really, I think one of the things we are seeing is a lot of these tools and technologies have been traditionally used by research and development groups, central engineering groups, and what the opportunity with sustainability as well as in traditional operations to bring all these tools and technologies online with real-time monitoring and automation capabilities. So you can do real-time optimization. You just don't have to do a design and throw it over the fence, right? You can do real-time optimization. You can have very customized dashboards that give you predictive insights. But now you can also innovate in the process itself. You can drive process innovation. Because what's happening today, we are seeing in many industries is things are not very static. The types of raw materials are changing. Vast difference in the quality of the raw materials input. And for example, right now we are seeing major automotive manufacturers setting up refining facilities for lithium.
Right.
because they are seeing this becoming a critical resource. So now there's going to be a wide range of quality and variation, the purity levels of materials that you get and compositions that you get. So how do you start doing them? So you can't really design necessarily for all of the sources of input. You need to have flexibility. So if you are able to get this idea of real-time monitoring automation established, that's a huge opportunity.
So where is the industry on that continuum of moving from a standalone test to real-time or even near real-time monitoring?
I think it's still early days.
Okay.
We are seeing a few operators who have actually embraced our real-time monitoring solutions and who are using it today. So, for example, in the mining space, we've been doing that with some companies recently. We've been doing that in the refining industry with certain customers who are using real-time monitoring to mitigate corrosion risk. We have a few chemical suppliers who do chemical dosing for upstream oil and gas production. And they are using some of these tools as well. But it's really not very widespread just yet. It's still in the early days. But I think this is the sort of the innovation wave. So what we are excited about is we are unlocking all of these technologies to basically design and optimize these complex processes built over many, many decades, which are very accurate, which is now in the, these tools are now in the hands of operators and producers who can now drive innovation in their process, unlike anything they've ever done before. And it's also interesting that now, like the area of sustainability, I think I was in a couple of sessions here, we're talking sustainability reporting. And a lot of these reports in sustainability today are very static. They're off of, just taking, some empirical data and understanding this, but it's not based on what's going on. These kinds of tools now and capabilities can now provide you real-time visibility and dashboards into what are your greenhouse gas emissions at any point of time. Where is it going, and not only where it is, but how will it change when some input conditions change, and what do you need to be looking out for in a more proactive manner, right? Those kinds of things are all possible in really bringing that entire piece together. And technologies like enterprise asset management and so on that are already doing these kinds of things can actually bring in much deeper insights. So we're really excited about bringing these kind of deep insights and plugging it into various other systems of record and systems of operations data that are being used to provide those insights in a much more.
I mean that's absolutely fascinating. Moving from the R&D lab over to a really the live process really is fascinating. We're just about out of time. Do you have any last minute comments for our audience?
I think check out our website, olisystems.com. We are happy to talk to you about our innovations, not just in traditional asset performance, but also when it comes to environmental sustainability and how we can really empower you with insights for design and optimization of complex chemical processes for your most valuable processes and drive meaningful outcomes for your business. So thank you for the time, and look forward to talking to more of you. And check out my colleague Lisa Williams' podcast as well, which is available.
That's right. We'll put a link in the description that's below this image. Again, our guest today has been Vineeth Ram, Chief Revenue Officer for OLI Systems. And thank you very much, Vineeth, for being with us today.
Great. Thank you so much.
Take care.
Thank you.